Hi, Chris here for Tech and welcome to the channel. Well, today it's all about understanding the RGB LEDs and how to use them. So let's get started now. Today we are going to learn how to use those LED because so far we use only individual LEDs color such as the red, yellow, green and even the blue one. But did you know we can get the red, green and blue LED all in one package? If you look closely here, we can see the different components, and with this package it is possible to get up to 60 million different colors out of them. So before we learn how to use the RGB LED or what's needed for the setup, let's study a little the RGB LED to figure out how these things works. RGB LED literally stands for red, green and blue, or RGB. You can get more details about how to get all those colors as well as the CMYK explanation with this video here, but let me know in the comment down below if you want to know more about it. Alright, the way we get all of these different colors is by adjusting the individual LEDs inside the package to be brighter or dimmer in order to get the exact color we want. To understand how we can do that, let's look at this wheel here with all the color of the rainbow in different areas, and then you can choose what you want from that. We have red, green and blue. Those are primary colors, but we can mix them to get the other color. The first things we noticed when looking at an RGB is that she has 4 legs. We call them leads. 3 of them are for each of the colors, and depending on the type you got, either a common cathode or a common anode. No need to panic, and this stands for positive anode, negative is cathode or panic. With that said, let's identify the 4 connections. You can determine those connections by the lead length. The longest lead is always the common connection. To the left of that, it's the lead for the red color. On its immediate right, we have the green lead. And on the far right, the shortest lead is for the blue connection. The 2 types of RGB LEDs are the common anode and the common cathode, as I hinted at it earlier. For this one, you can see that the cathode LED is the ground pin. This is where the negative voltage is applied. As for wooden type, it is called a common anode LED, where the anode is connected to the VCC pin or to the 5V. And so it is obvious that one of the legs is longer, and that longer leg is for the grounding, may it be anode or cathode. Most of the kit out there will use a common cathode anyway. It's always good to be sure, and you can verify this with this coin cell, inserting it in between the anode and the top pin. If it doesn't work, we just have to flip the cell around. Let's try this. Sorry for the focus. Okay? Since it doesn't work, I flipped the cell around, and now when I connect the 2 leads, you can see it turned on. Good. So now let's try it with the other one. You can notice that the common here, it's with the plus side. And if I take this RGB here, you can see that it doesn't work. But if I flip the connection around, it's the same as flipping the battery, by the way. You can see that it works. Okay, it is important to know that not all the LEDs are equal. As it is mentioned in this video, we need to know that it's important to match the proper resistor for each LEDs. And this is why I created those 2 programs that you can see here. Let me know in the comments down below if you want to have more details about that. Over here, this is how the 2 RGBs are connected. You notice that normally the red LED needs a bigger resistor than the rest, and this is due to its voltage drop being lower than the 2 others. The other option we have, and that's the one we will use, is to have a bigger resistor for all. That's why we will use a 220 ohms for the demonstration. With this, the LED might be dimmer, but in the long run, this will preserve them. And this is good to know. Now, if your LED has the leads color or has been trimmed, you can still determine the orientation by looking at the flat side of the case. Here, that indicates the red LED side. And if we have a closer look, I will show you where all the LEDs are situated. We know this is the red, then we have the green one, and lastly, the blue LED. This one here, it's for the common. And here you can see another close-up of the LED, where each LED lights up. This is when it's all fully light up. Then we have the red color, then we have the green color, and finally we will have the blue color. Okay, it's practice time now, so let's start with the setup from our last video. You can either pause here or look at our Arduino tutorial number 14. And here it's the full code. I send this to the Arduino and we can verify that it works. We do this before switching to the RGB, and this is to establish how the code works. We turn on the red, the blue, the green and all the LEDs before turning them on. Now we test those. We can proceed to remove the LEDs and let me demonstrate how to connect an RGB LED. We will start with a common cable. First, you see me here adjusting the leads in order to make them fit in the breadboard. Of course, we will go with a red LED situated at the top of the screen. We need to make sure that the connection for the LED is firmly secure, like so, and we can remove the resistors. Once this is done, then we adjust the wire for them to match the RGB leads. And yes, I have some difficulties to remove this little one here. They are quite practical, but difficult to remove. And it is easier to add the common first, to me at least. Notice how I did not disconnect anything from the Arduino, only on the breadboard side. Then, to help me further, I will go with the corresponding resistor. Although it's not necessary, I still straighten the leads. With this, I can bridge over to the other side of the breadboard to leave enough space for the wire coming from the Arduino. Oh, hey look, I put a mess here. Let me adjust this first. I finished the connection. If you remember, for our circuit, I choose not to match the exact resistor. I go above with all of them being 220 ohms. And this, although it makes the LED a little bit dimmer, it will prolong the LED's life. I do have an upcoming video about the resistor to find the correct wattage and so on, if you like so. As you can see here, I'm having a little bit of difficulty putting the last one in, but here we are. At this point, we can now connect the corresponding wires. And it is at this point that we notice we have too many wires, so we need to remove the one we don't need. And this is the yellow one. So I remove this one, and we can now connect them accordingly. Starting by the red one, then we have the green one, and finally the blue one. So this is done, we can bring the sketch and test if the connection is working. Now this is done, we can bring in the IDE without changing the sketch. And in the serial monitor, starting with the red, and it works, the blue is okay, then the green, no surprises here. But if I turn all of them on at the same time, then we get a white color, and this is normal. Now I turn them all off like so, but you can see that it flickers. We just have to adjust the wires by fiddling a little bit with them. Once you've done that, then as you can see, it's okay. Now it is time to try the common anode. We have to adjust the wire to the corresponding leads, of course. We will start adjusting the leads in order to make them fit in the breadboard, and we will change the common black wire to a yellow color one to make sure we understand that it has to be into the VCC or the 5 volt, like so. Now let's try the code again. We start with the red, but we got cyan, huh? Then the green, we got purple, the blue. Will it be okay? Nope, we got a greenish yellow instead. How peculiar. And what happened if we turn all of them on? The RGB turned off. But if I turn all of them off, then the RGB gets into a white color. Is this normal? Well, let's turn it off again. As I did mention, this is a common anode, so yes, it is normal. And we notice that all the connections are fine. Then it must be inside the codes. Let's close all of this to understand what's happening in the code. And if we remember, when we turn it on, it turns off. Basically, if you are using an anode, you have to inverse everything in the sketch. So high would be off and low would be on. And of course, once we change this one, don't forget to copy it throughout the sketch. So now we will change the setup, put both RGBs in the same breadboard, and of course I will adjust the code. Here you can pause to see the connections if you wish to. Let me know in the comment down below if you want me to do a details connection. By that I mean not having the picture. So as you can see, I update the pins, the red, the green and the blue for both RGBs. The first set is R pin and the second set is R pin A. If you notice what I changed here in the void setup, or set them out as an output here, And if you notice what I changed in the Arduino, it is basically what I said earlier. When it is set to high for the common anode, the RGB, it's off, that's why it's actually marked as low here. And I repeat this throughout the sketch. So now we can send this to the Arduino, open the serial monitor, and check the color and see if it works. Starting with the red, then the green, then the blue, all fully lit, white color if you prefer, then we turn them off. Okay, now we are going to have some fun. We close this to demonstrate how you can make your own custom colors, and if you look into the sketch here at the bottom where we already changed it and added a few more lines of codes, let me explain how this works. So for now, I just added those two colors here, cyan and yellow. If you've noticed here, we have changed the digital write to an analog write. For those who are not sure about why we do it that way, you may want to look at this video here. But feel free, and this is your assignment actually, to create as many as you want, or change to a different shade that match best your mood. Then you can share with me in the comment down below. And how you can change a color by adding or subtracting a number from here. And this will change the color. So let's send and test this. We will be starting with the red, then the green, then the blue. We will do the cyan. We already know that this will not work, and this has to do with the way cyan is spelled in the sketch. If you noticed that earlier, that is, once we spell it as it is in the sketch, like this, then it works. This is another thing we need to be aware when creating a code with user in mind. Alright, we can resume with a yellow and fully lit. Then we turn them off. Now you can see that I bring over a diffuser. I use what I have on hand, but note that you can use a ping pong ball if you want, so just have to drill a small hole in it, and we try the colors. The red, the green, the blue, the cyan, the yellow, and fully lit. Now I can turn it off and remind you that I have a giveaway for my 100 subscribers, so please look at this video to know more about how to enter and win those prizes. I hope this video was useful to you. That is it for today. Thank you for watching the video, and just to let you know, I started a Patreon where if you want, you can support me. And again, if you enjoy it, you know what to do. You can do your YouTube things, like if you want to subscribe, you may as well. Or you can also press the bell icon if you want to be notified every time I post a new video. However, if you do not like this video, simply leave a comment down below and tell me why it's so. I will try to do it for you guys. Stay safe and bye now!